and pulled out a very sharp curve in the city there. And we started analyzing kind of what the behavior was on that road. So if we took those probe points for initial speed between 50 to 60 kilometers per hour, and then plotted in pink there is the first point of brake application. So that's when they started to slow down. We have one fellow that waited until the last minute. I don't know what happened to him. He may have been in the ditch or in the tree over there, I'm not sure. But that's why we take the centroid of that information. It's because what we want to do is we want to build out kind of the wisdom of crowds for driving, so that we understand kind of this is how people drive this road. So that if someone's coming in there that's not experienced that curve before, they're getting upfront information about there's something ahead, you're maybe going a little bit too fast. These are alerts, not control, not autonomous vehicle, but more like just alerts. Maybe you're going a little bit too fast. So we find that where they hit their brakes on their way through there is different based on the speed, of course. And what this is a product that we offer right now called ADAS, an Advanced Driver Assistance System for automotive to understand kind of the dynamics of the road. So this is a spline representation of this road. The red porcupines are the curvature, and that gives information about what the dynamics are you're going to experience up ahead. So you see here, there's kind of an S curve ahead of this, and then you go into the sharp curve. This is just a straightaway on its way down through. So that's our first point of braking as a function of speed. Now what's interesting is because we have that ADAS spline, we can calculate the lateral acceleration of the vehicles as they go through. So it's kind of that G-force you feel as you go through the curve. And you can see here, this is their speed as they go through. This is a northbound profile. They're coming from this side and they're heading there. They're slowing down, and then accelerating through the curve. What was interesting is we have a very dramatic curvature on the road itself. But in fact, when the people went through the curve, they had kind of a flattened lateral acceleration as they went through, which indicates to us that there's probably a comfortable lateral acceleration that people take curves at. So even though they could maybe take it faster, everybody kind of took it at that same lateral acceleration, which is really interesting for us in terms of autonomous vehicles someday, because you really want the vehicle to drive like a human drives versus how a R2D2 would drive it, right? So you get a much better understanding of kind of how the wisdom of crowds again, of how people want to experience a road network. Interestingly enough, and not surprising, because we have an S curve this way and we have a straightaway that way. If you're coming southbound, the profile is completely different. So now you can start layering on top of our map kind of behavior information about how people really like to experience the road network as opposed to how it was designed to be experienced. And civil engineers, for example, would love to have this kind of information so that they know where to put the signage and maybe learn from how to design curves like this. Even better is now we can introduce that windshield wiper, and now we can say, they do something completely different in rain, and they'll do something completely different in snow, or night, or day. And so you can see this layering that could occur on top of our map that gives you situational information about how you should behave, or we would suggest you behave as you're coming into these situations. So lots of opportunity there, I think, from a safety perspective.